Beta and gamma functions. Definition of a beta function. The definite integral integral 0 to 1 x to the power of m minus 1 1 minus x to the power of n minus 1 is called the beta function. And it is denoted by b of m n. So integral 0 to 1 x to the power of m minus 1 and 1 minus x to the power of n minus 1 is called the beta function. So beta mn is equal to this function. Here m greater than 0 and n greater than 0. Now we will look at the properties of beta functions first. So first property, beta mn is equal to beta nm. So this is the first property. Now we are going to prove this property. So for this proof, first we will consider beta mn. From the definition, beta mn equal to integral 0 to 1 x to the power of m minus 1 1 minus x to the power of n minus 1 dx. This is also dx. Now put 1 minus x is equal to y. So this implies what is x? From here, what is x? Minus x is equal to y minus 1. This implies x is equal to 1 minus y. Then dx is equal to minus dy. Okay, now beta mn equal to integral 1 to 0. Why we are changing this integration instead of 0 1 and 1 0? So here keep x is equal to 0. When x is equal to 0, this implies y is also 0. So when x is equal to 1, y is equal to when x is 0, y is 1. When x is 1, y is 0. Here substitute x is equal to 0, y is equal to 1. X is equal to 1, y is equal to 0. So this is integral 1 to 0. What is x? 1 minus y. 1 minus y to the power of m minus 1, and 1 minus x is y. Y to the power of n minus 1, and dx is minus dy. Okay, now this is equal to integral 0 to 1. Because minus is there, integration will changes to up and down. So this is y to the power of n minus 1 into 1 minus y to the power of m minus 1 dy. So this is equal to integral 0 to 1 x to the power of n minus 1 into 1 minus x to the power of m minus 1 dx. Why we are writing like this? If integral a to b f of t dt is equal to integral a to b f of x dx. So it is in the form of y, but we are writing it in the form of x because of this property. So this is equal to, this is of the form beta n comma n. So beta mn equal to beta n. So this is the proof of property 1. Beta mn equal to beta nm. Consider beta mn. This is the function put 1 minus x is equal to y, then my x is equal to 1 minus y, dx is equal to minus dy. So when x is 0, y is equal to 1, when x is 1, y is equal to 0. So change the integration. So this is y is 1 minus y power m minus 1, and 1 minus x is y to the power of n minus 1, dx is minus dy. So this can be written like this. Because of the minus, we are interchanging the limits. So this is equal to integral 0 to 1 x to the power of n minus 1, 1 minus x to the power of m minus 1 dx. So this is nothing but beta n m. So this is the first property. Now we will look at the second property. Second property is beta mn equal to 2 into integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. Okay. Now we are going to prove this. Consider beta mn. From the definition of beta function, it is integral 0 to 1 x to the power of m minus 1, 1 minus x to the power of n minus 1 dx. Here put x is equal to sine square theta. Put x is equal to sine square theta. Then dx is equal to sine 2 theta d theta. That is the derivative. So therefore beta mn equal to integral 0 to pi by 2. Why we are writing 0 to pi by 2? In place of x, if we put 0 is equal to sine square theta. So when sine is the 0, when it is 0, and if we put 1 here, 1 equal to sine square theta. When we will get sine theta as 1? If it is pi by 2. So the limits are 0 to pi by 2 sine square theta, because x is sine square theta to the power of m minus 1, and 1 minus x, 1 minus sine square theta to the power of n minus 1, and dx is nothing but sine 2 theta d theta. So this is equal to integral 0 to pi by 2 sine 2m minus 2 and 1 minus sine square theta is cos square theta. So cos square 2n minus 1, cos 2n minus 2, and sine 2 theta can be written as 2 sine theta cos theta d theta. Okay, so this is equal to, bring this 2 outside, 2 into integral 0 to pi by 2. This is sine 2m minus 2, and here 1 sine theta is there. So 2m minus 2 plus 1, that is 2m minus 1. Here cos 2n minus 2 and 1 cos theta is there. Cos 2n minus 1 theta d theta. So this is the required answer.